What's up, boys and girls? Welcome back. It's Mr. Irwin bringing you today's math lesson. Today we're going to start working with data distributions by visually representing data sets, and that first visual representation is on the screen. It is called a line plot. So please grab a notebook, grab a pencil, grab a calculator, and work along with me as we discover the wonderful world of line plots. So you notice on the screen we have a definition for a line plot. A line plot is a graph that shows the frequency of data along a number line. The key to this is it is graphed on a number line, and really the purpose of it is to show the frequency or the amount of times each data element occurs in a set by giving us a visual display. Let me show you what a line plot looks like. So on the screen down below we have a line plot, number line across the bottom, and then we have dots representing each element in a set above that number line. So the example says the line plot represents the number of tickets to the festival sold by individual students, and it asks us to calculate the mean, the median, and the mode of this data set. So what I want to do first is actually create the data set that this line plot or dot plot represents. This first dot is above a 3, so that represents an element of a 3. And now I have 2 dots above a 5, so those represent 2 elements of 5. 3 dots above the 6 means we have 3 6s, 2 7s, 1 8, and 1 9. Now let's calculate the mean. First step in calculating the mean is to sum the digits. So I'm going to grab my calculator and let's add these values together. 3 plus 5 plus 5 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8 plus 9, I get a total sum of 62. And I'm going to divide that sum by how many elements were in the set. There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the set. So we are dividing by 10. And I get a mean of 6.2. Next, the median. To calculate median, we arrange the values in order, which they already are, and we're looking for the one in the middle. So right now I'm going to start eliminating endpoints. I have a 3 and a 9 on the end, so they can be eliminated. Now 5 and 8, 5 and 7, 6 and 7. I'm left with 2 6s in the middle, so I add those together. 6 plus 6 is 12, and 12 divided by 2 gives me a median of 6. And finally, we're calculating the mode, which frequency occurred most often. You can look at your number set, but this is where a line plot is extremely useful because the mode, the highest frequency, will be the highest peak of the data. So we have the most elements on 6. So the mode is 6 as well. All right, our next example. Line plot. This line plot represents the number of miles members of a cross-country team ran in 1 week. Calculate the mean absolute deviation. So I'm going to set up my mean absolute deviation table, and my data points are, I got 2 4s, 4 and a 4. I have a 6. I have 2 8s. I have 4 10s, 1, 2, 3, 4, and I have 5 12s. 1, 2, 3, 4, 5. All right, so let's calculate the mean of these numbers. So summing the digits, 4 plus 4 plus 6 plus 8 plus 8 plus 10, 10, 10, 10 plus 12, 12, 12, 12, 1, 2, 3, 4, and 5 12s gives me a sum of 130 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in the set. Gives me a mean of, we're going to round to the nearest tenth, 9.3. Now it's time for our deviations. Remember to calculate our deviations. We are taking out each data point and subtracting the mean. So first off, 4 minus 9.3. I get a deviation of negative 5.3. And don't forget, those deviations need to be absolute. So we are making that the positive version. So both 4s have a deviation of 5.3. Next, we have a 6. We're going to do 6 minus 9.3. Gives me a deviation of negative 3.3. And we want to make that absolute. So positive 3.3. Next is the 8. So in our calculators, we're typing 8 minus 9.3. A deviation of negative 1.3, make it positive. So both 8s have a deviation of 1.3. And now we have 10. 10 minus 9.3 gives me a deviation of 0.7. It's already positive, so I don't need to worry about it. Each 10, deviation of positive 0.7, so I got 4 of those. And then finally 12. 12 minus 9.3 gives me 2.7. So all 5 of these 12s have a deviation of 2.7. And now finally, the mean absolute deviation we're going to calculate by summing those deviations and dividing by how many there are. So 5.3 plus 5.3 plus 3.3 plus 1.3 plus 1.3 plus 0.7 plus 0.7 plus 0.7 plus 0.7, and now the 2.7s plus 2.7 plus 2.7 plus 2.7 plus 2.7. What do I lost count of how many I have? What do I have? 1, 2, 3, 4. I need 5 2.7s. And there we have a sum of 32.8. And remember, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 elements in the set. So when I divide 32.8 by 14, I get a mean absolute deviation rounded to the nearest tenth of approximately 2.3. All right, the next thing I want to talk about are distributions, or the shapes of our data. So if you'll notice, we have 3 different graphs down below, and I want to start with the one in the middle. So if you get a graph or a line plot that makes a shape that peaks in the middle and both sides fall relatively the same on both sides, we call this a symmetric or a normal distribution. And in a normal distribution, the mean and the median, they're going to be very similar to each other. Over here on the left, if my data peaks on the right and then kind of tails off to the left, we call that data set to be skewed left or negatively skewed. And in a negatively skewed distribution, the mean gets pulled towards the skew. And so because it's skewed left and the mean is being pulled left, the mean will always be less than the median in a skewed left or a negatively skewed distribution. Conversely, we have the other direction. If I have my peak on the left and a tail swooping to the right, we would say that this distribution is skewed right. And in a skewed right distribution, remember, the mean gets pulled in the direction of the skew. So the mean would be pulled to the right on the number line, making it a greater value than the median. Let's go back and look at the 2 dot plots we've already talked about and see if we can determine their distribution based on the shape of the data. So here's my data distribution. And if I actually draw the shape of those dot plots, I get a peak in the middle with about the same fall on both sides. So I would call this a normal or a symmetrical distribution. And in a normal or symmetrical distribution, the mean and the median should be about the same. And if you check our calculations, yeah, 6.2 and 6, pretty close to each other. Oh, the other dot plot we did, I put it upside down. Let's take a look at this shape. So I have all this data over here. And if I draw the shape of it, my peak is on the right with a tail swooping to the left. Remember, the skew or the tail is in the direction of the skew. So we would call this skewed left or negatively skewed. That means if we would actually calculate the mean and median of this, the mean would have a lesser value than the median. All right, I have one for you to try. This line plot represents the time each of Ms. Smith's students studied for the test. I want you to calculate the mean, the median, and the mode, and then describe the distribution. When you're done with your work, come back and check to see how you did. All right, so let's see how you did. First off, the mean, the median, and the mode. So if I was to take this data set, I have a 0. I have 1, 2, 3, 4, 5 tens. 1, 2, 3, 4, 5 tens. 1, 2, 3, 4, 5, 6 20s. 1, 2, 3, 4, 5, 6 20s. 3 30s. 2 40s. 2 50s. A 60. And an 80. So I want to find the mean of all of those. So first I'm going to add them up. 50 plus 90. I get a total sum of 580, and there were a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 elements. We divide that by 21, and we're rounding to the nearest tenth. We get a mean of 27.6. Median, the middle number, is at 20. Mode, which occurred most frequently, our highest peak is at 20. And then if I look at this shape, how would you describe the distribution? I would say that this is skewed right. Peak kind of on the left with a sweeping tail to the right. Also, look at our mean and our median. The mean is greater than the median, and that tells us that the mean is being pulled towards the skew. It's being pulled towards the right, which gives it a greater value. Boys and girls, make sure you complete your independent practice assignment on line plots. Take a picture of your work and upload that file for submission. I'll see you guys next time.